Yeah, I'd just like to thank uh, Richard Miles and Jim Stryker for organising this event at Mullaney. Mullaney is a very interesting community because people usually go there because of the environment. A lot of people go there, and they're very environmentally conscious people. So it's a very interesting community. And I'm here to talk about today about the Australian guidelines that we use to regulate this wireless radiation. My background is I did applied physics and then went on to do a Master's of Science at Melbourne University. I've worked for 54 years as a radiation protection scientist. And my experience, I've been in government. I worked for ARPANSA when it was called the Australian Radiation Laboratories for a decade. I worked in the uranium mining industry, and I'm also a member of I'm a fellow of the Australasian Radiation Protection Society. I was an inaugural member there back in 1975. So I've actually got quite a lot of experience in this area. But as most of my colleagues, when they work in this area, they work in the area of what's called ionising radiation, that is, X-rays and gamma rays. And this non-ionising radiation, this wireless area, there are very, very few jobs in this area. So a lot of my colleagues are very ignorant of the effects of the long-term effects of this wireless radiation, and I really haven't looked into it. And when I give a talk at the Australian Radiation Protection Society conferences, a lot of my colleagues come up afterwards and said, "Look, I haven't really looked at this, but yeah, I can see where you're coming from. It's actually it's quite interesting." So so, as I said, I've worked in the area for over 54 years. And just prior to my retirement, I used to do a lot of consulting. I'd go overseas and I was consulting on atmospheric dispersion and radiation issues. And a lot of in the last 2 years, prior to my retirement, I actually worked as a radiation safety advisor at Queensland University of Technology. And then I went on after that to help commission a cyclotron, produces isotopes for PET scans. So and I'm just going to give you a bit of my discovery in this area, how I came to actually discover that, hey, this is a bit different to this ionising radiation, these X-rays and gamma rays. And most of my colleagues in this area, in the non-ionising radiation, it's usually worried. Their worry is usually ultraviolet light, or UV radiation, or lasers is really what is in the workplace. These are the issues that they look at. But so this wireless radiation, as I said, there's very, very few jobs. And so there's a bit of ignorance around this. And as I said, my colleagues work with X-rays and gamma rays. They're working in hospitals. They're doing therapy. They're using large doses for cancer treatment and that. So this radiation they see as being very low level and really not a problem. Anyway, at QUT, a young lady, when I started working at QUT, a young lady approached me and she said, "Oh, I was part of the occupational health and safety unit at QUT," and the young lady approached me and she said, "Look, I've had a lump removed from my breast, and what I used to do is I used to put the mobile phone in my bra. And is it possible that the mobile phone could have actually given me this cancer?" And she was a young lady, she was probably about 24, and she'd been doing this for a number of years. And I said, "Look, I don't really know. I don't know much about this wireless radiation, this non-ionising radiation." I said, "As far as I know, it's sort of quite safe." And she said, "Well, could you have a look into it and get back to me? So what I did is I rang a colleague of mine who worked for Motorola. He was at Telstra Labs out at Clayton in Victoria. I'm working in Victoria. When I was working in Victoria, Clayton, the Telstra Labs were out at Clayton. And anyway, I rang him and I said, "Look, you know about this wireless radiation. Is it possible that this young lady could have got a breast cancer as a result of putting in a bra?" And he basically brushed me off. He said, "Look, Vic, people get breast cancer for all sorts of reasons. No, it's got nothing to do with it. It's not a problem. This issue. It's basically, it's a non-event." And I said, "Oh, okay, well, thanks for that." But I've sort of got a bit concerned at the way he sort of talked to me, like I was like, he just, as I said, just brushed me off. And then there was a research librarian. She worked on the top floor, the eighth floor of the library, and she called me up and she said, "Would you come over here quickly? The telecom engineers are putting out mobile phones on the top of this building, and I'm really concerned about it." And I said, "Well, hang on, I'll come over." Anyway, she said, I said, "Why are you so concerned?" She said, "Well, I've had a vagus nerve tumour removed from the back of my ear, and I'm terrified. The surgeon who resected it said, I said, 'Well, how did I get this?' And he mentioned mobile phone use. And she said, 'I have been a heavy user of mobile phones.' And I said, 'Oh, right.' Anyway, she said, 'Well, can you come and do some measurements in this area and show me that it's safe?' And I said, 'Yeah, I think I'll get the equipment.' I said, 'I don't have the equipment to do it, but I'll purchase the equipment and I'll start measuring.' But I said, one of the things is that you're under the tower, you're in the shadow. I wouldn't have thought it would be this would be a low background area. The panels are pointing outwards. It shouldn't really. The background levels really shouldn't change." So I went over there to got the equipment and installed it just before they put the towers up, and started doing some background measurements. And I was sort of really concerned because the levels were a lot higher than what I thought. And then I looked out the window and I realised that on the other buildings around, there was all these towers, and they were all pointing towards, and they were along the side of the building as well. And I thought, gee, that's quite interesting. And then as I said, I moved on to help commission a cyclotron, produce F18 for PET scans, and over at University of Queensland, and help write up the safety manuals and associated with working that cyclotron. And I met some people who were electro hypersensitive, and I didn't think that was a problem. And then just to talk a little bit about the transfer of energy. With ionizing radiation, X-rays and gamma rays, the wave is very small, the size of atoms. So it interacts with molecules and atoms. So as X-rays go through the air, they ionize the air. Because it interacts with the atom and dislodges the electrons off the atom. And so it's ionization. So that's like a fast burn. But UV light, ultraviolet light, and this RF radiation would be what I consider slow burn. It would happen over a long period of time. People get skin cancer. It's not something that happens instantly. It happens over a long time. So I consider that to be like a slow burn. And then getting back to the young lady who with the breast cancer, I started doing a little bit of research, and And I discovered there was a medical surgeon, a breast surgeon, who noticed that the tumours in the breasts of some of these young ladies who were in their mid-20s who'd been putting the mobile phone in their bra for a number of times, the tumour wasn't actually a nodular tumour, it was actually in a line. And you can see there the actual resection. So he put out a message to all these other breast surgeons because to say, have you seen this? So he was alerting his colleagues to a potential problem. The other thing, there's also a few papers starting to pick up on people using mobile phones in their putting them in their pants pocket, and they noticed that there's quite a few tumours that have been resected from where the phone was in the pocket. The actual tumour had formed, and these tumours were what are called schwannomas. They were swan cell tumours. Again, it was sort of quite interesting to see that as well. And then there was this chap who used a mobile phone for 6 hours a day, who was convinced that the mobile phone he was using was a result of his use of the mobile phone. I wondered at the time, why would anybody use a mobile phone 6 hours a day up to their head? Obviously, he thought that these devices were toys. They can't hurt you. That's what we're being told. They have no effect. You might not be aware, but the Interphone study back in early 2000, 2004, which was an industry funded study, there was some suggestion that as a result of the long use of mobile phones, that it was an agent for causing these tumours at the back of the ear. And so the mobile phone companies, they didn't tell anyone, but they actually moved the antenna of the phone from the top to the bottom of the phone, which I thought was quite interesting. As I said, this radiation seems to be have an effect to the swan cells. These are the cells, the myelin sheathing, the cells around the myelin sheathing. The actual radiation seems to be these cells seem to be quite sensitive to this radiation. And there was a series of court cases in Turin in Italy over people getting these swan cell tumours, these tumours that metastasise of the cells in the nerve sheathing. And there's actually now been 6 cases. At the time, there was 1 or 2 cases. There was an appeal. The telecommunication companies said, look, it's not due to the phones. There was an appeal. And that appeal, they lost the appeal, and it was upheld. And these, I think it was 2 or 3 gentlemen were awarded compensation for the fact that it had caused damage to their it's called an acoustic neuroma to these swan cell tumours. That's most of the time they're benign, but sometimes you can also get what that other chappie got was a glioblastoma. These are metastasization of the brain cells. So there's six cases so far in Turin, and that was quite interesting. Anyway, I met Julie and I met Steve Weller, and at University of Queensland, Julie was working there as a cognitive scientist, and she was a bit concerned about this radiation and the fact that it was now being rolled out in all the classrooms. And she and Steve had done a lot of work on looking at effect paper, what biological effect it would cause. And I'm not talking about the short-term heating, I'm talking about long-term biological effects. So we decided to form an association, a not-for-profit association, and we sort of recruited people, a lot of retired people from industry and non-industry. We needed a range of people with different. I'm not a biologist, and we needed doctors. We've got quite a few doctors involved in our organisation, although their name doesn't go up in lights. They're very aware of the government's position on this, and but they're still there. They advise us, and we started looking at the papers, and we decided possibly might be a good idea to set up a database and start collecting all this information. And we also have supporters, associate members. Some are teachers, accountants, nurses, but we're an advocacy group. We're not an activist group. We won't get out there with placards. We're about the science. We want to understand, is there a problem here, or if there's not a problem? And we're all volunteers. I just want to say something about the electromagnetic spectrum, because this microwave area here is where this wireless communication is. And you'll notice that part of the electromagnetic spectrum is the visible light area here. And I was a bit intrigued. Some time ago, I was listening to Dr. Carl on the radio, ABC radio, saying, "Oh, it's not a problem with this technology. It's perfectly safe." And he said, "Look, visible light. It comes to Earth 100 times, 1,000 times greater. The power density per square metre is so much higher than what we're producing with this wireless radiation. It's not a problem, But then he didn't really tell the full story, because this visible light that falls to Earth is a whole lot of different. It's broadband. It's a whole lot of different frequencies. It's different colours, and it's not polarised. And what I mean by that is, when it hits a glass, reflects off a glass, or it reflects off water, off a surface of water, the reflections are partly polarised. And what that means is that all the waves are in sync. They all go up together. And of course, that reflected light stings your eyes. So you go and get polarised glasses. So this man-made radiation that we're creating is totally polarised. It's all in sync. It's all going up and down. And you can probably see in the corner here what I can call constructive interference. It'll add up, but it also will subtract. So you get constructive and destructive interference. So this man-made radiation that we're creating in this wireless area is totally different to visible light. And if we take visible light, for example, and we totally polarise it, we actually produce a different sort of light, and that's called laser light. And the minute we do that, we've got a health problem, right? So that's what we're doing in this area, in this microwave area, with this wireless communication, is we have these totally polarised waves. They're all going up and down together, and they can add up. I just wanted to say that. I think Julie covered it a little bit in her talk as well. So what's been happening over the last 50 years, 60 years? Well, this is the background. The background has gone up. The green there is the natural background. Every year we've been increasing in this microwave area, we've been increasing the background. And the background has gone up a quintillion times now, okay? It's gone up a quintillion times. That is a 1 with 18 zeros. And we're pushing, and we're putting more and more of this wireless into technology all the time. We decided to look at the science, and Steve had collated a lot of papers and that. We decided to gather all the papers together, all the research papers, the experimental papers, the review papers, all the different types of papers, which is scientific papers in the literature. And we concentrated on what we call non-thermal effects. That is, levels at much lower, below the heating effect. And this is what we found. We found that 50% of all the papers were in this in vivo and in vitro. Now, in vivo are animal studies. They're usually rats and mice, but there are some primates in there. In vitro studies, these are cell studies. The thing about having animal studies is you can control the environment that the animal is exposed to. Whereas when you do epidemiological studies, which are mentioned here, which is disease studies, you need to get a population group that's exposed and a population group that is not exposed. And one of the problems is we've got lots of interference in doing disease studies. Is it due to the pesticides, microplastics? What effect are they having? They're very difficult to do, these review studies, and there's statistical association studies. But the animal studies and cell studies, particularly the animal studies, are most preferred because we can put the animal in an environment where it's exposed. It has the same food as the control group. We can control what's going on. And of course, most of the toxins that animals that we see in rats and mice, we also see in human beings as well. And then we've got what we call human provocation studies over here, 7%. Now, these are the sorts of studies, they're sort of silly studies. They have a person in a room with an antenna and they flick on the antenna and they say, "Do you feel it?" And yeah, I mean, there's, it beggars belief but these are the sorts of studies we've been doing in Australia. We spent millions and millions of dollars doing these human provocation studies, and they're sort of, I don't know, bit like black magic in a way. And then you've got these review studies, and these review studies are quite interesting. Is where they get together a collection of papers. They look at animals that are exposed to certain levels of radiation for certain periods of time, but you've got to look at who's funding the review study. If it's industry who's funding the review study, you're probably going to find a no effect. If it's government grants and universities, you're probably going to find an effect study. So review studies, you need to look at who's actually funding the study, which is very, very important. And I'll talk a bit about that later on. But currently we've got 5,370 scientific papers. We asked ARPANSA and they were very gracious. They gave us a spreadsheet with their 1,354 papers in it. And we also got Professor Henry Lai's papers. So we put those into the database as well. So we collated all the information, but we didn't just look at just biological effect studies. We also looked at no effect studies as well. And those studies also, there's a few of those a bit uncertain. They weren't sure whether they really saw the effect or they didn't. They were uncertain. So we didn't just focus on the effect studies. We also focused on the no effect studies and those uncertain studies. And we developed, I've got a lot of experience in database development, and we developed a database to do that, and that's readily available online. You can go on there, do searches, and there's a bit of a training period in using the database. It's a technical database, and you can look at various endpoints, but you can select an endpoint like, I want to look at all the papers that show brain tumours. I want to look at all the papers that show mitochondrial damage. energy damage of the cell. I want to look at those. So you can actually do searches, and then you can produce a spreadsheet and download it, and then you can go and get the papers. So we did that. We put an online database, and we've been doing it now for quite a few years. As I said, also we've just celebrated our 10 years, 10 years of being there and publishing. And what we found was, and as I said, just those animal studies are quite interesting. We found that 82% of all the papers showed biological effect. Okay, different biological effects, but biological effects all the same. And there are quite a few. Only 13% there you can see of those animal studies show no effect. And you look at the cell studies, and you see 76% of studies showed biological effect. But okay, when I mention this to different biological scientists, they say, oh, well, yeah, okay, a biological effect, but, will this turn into a health effect? And you don't know, long-term health effect after many, many years of exposure. One of the things about animal studies and rats in particular, I mean, they only live for 2 years, so you can do a long-term longitudinal study over a 2-year period, which is quite handy because you can see whether in fact they're being these bioeffects turn into long-term health effects for the animal. The findings we got, and this radiation classified by IARC, the International Agency for Research into Cancer, they part of the WHO, it's a class 2. It was classified as a class 2B, carcinogen. That is a possible human carcinogen. And the reason they classified that back in 2011 as a possible carcinogen was because they didn't have the long-term animal studies. They said, oh, look, we can see all these bioeffects, but we need to see these long-term animal studies. They were all these short-term studies. And what do we find when we collate the papers in different areas? We find oxidative stress. When your cells are under stress, they produce reactive oxygen species. We can see, it was causing stress in stress studies. Sperm testicular damage. Lots of studies there showing that sperm is affected by this radiation. In particular, DNA damage, production of reactive oxygen species, or lipid peroxidation, cell death. And so there's quite a few studies in that area. And damage, genotoxicity, there's quite a few papers there. Immune system, affects the immune system. Cardiovascular, a lot of people who are electrohypersensitive complain of their heart racing or pulsing. When they get near a router or a mobile phone, they don't feel well, and their heart starts becoming erratic. And these long-term animal studies, one that was just concluded not very long ago, was the US National Toxicology Program, $50 million study was commissioned by the Food and Drug Administration in America. It was a 2-year study on rats and mice. And what they found was these swan cell tumours in the hearts of the rats. Clear evidence that the nerve sheathing was metastasizing in the hearts of the rats. You've got to remember that, these are whole body exposures. They can't put a mobile phone up to the rat's head. It's not like that. They put them in cages, specially developed reverberation cages, and exposed and control group, very specialised research, and they saw clear evidence of GSM and CDMA exposures, clear evidence of schwannomas, these in the hearts of the rats. In the female rats, it was what they call equivocal evidence. It wasn't clear evidence, but it wasn't no evidence. And brain tumours, these gliomas, these chap who was using a mobile phone 6 hours up to his head per day, that type of tumour was also seen, some evidence of that in the male rats and also in the female rats. So that was a very interesting program. It was concluded in 2018, they took them a long time to get going. They were asked to do the study back in 1999, and they didn't really get underway until I think it was like 2014, because they had to build the reverberation chambers. There's quite a lot of work in setting up to do these exposures. Anyway, of course, the industry wasn't very happy and is trying to challenge this result with other studies that they're doing, mini studies to try and challenge this result. But it's a very important finding. As I said to you about review studies, you've got to look at who's actually funding the review. And I did this some time ago, in 2018. I teased out the data, and you'll notice there's when industry's funding the study, there's a lot of no effect studies. If government and communication industry are funding the studies, again, a lot of no effect studies. If there's government funded or grants without any industry involvement, you find there's a lot more effect studies. And so that clearly this is a bit of a problem, particularly in universities today, because the research doesn't get done unless industry is actually funding the research. Brain cancer's on the increase. We're seeing that in England, glioblastoma, these terrible brain cancers that you basically, when you're diagnosed, you're virtually, you're going to die within a couple of years. Also, the same, they looked at in Denmark, they see an increase in these brain tumours. And ARPANSA did a similar study here in Australia, but they didn't do the over 60s group, which is my group, which is very important. There's a bit of criticism about that. Why didn't they do the over 60s? And they did look at, eventually they did look at the over 60s group, and they came to the conclusion that, yeah, there was a bit of an increase there, but it's probably due to better detection techniques. Well, that doesn't make a lot of sense, because as I said, when you detect the tumour, you're actually probably only going to live 2 years with a bit of luck. And conclusions, the Americans actually carried out a study and saw a twofold increase in brain cancer incidence in the last 2 decades. And they said, oh, yeah, okay, we looked at whether better detection techniques, CT scans and MRIs would have an effect. And they said, yeah, maybe, but it's not the full answer. It's 20% of the full answer. There are other factors involved here. Man-made radiation, it's got a bit of a Trojan horse there. As I said, when they do those provocation studies, they do show changes in the brainwave patterns, because this radiation isn't all high frequency, it's pulsed. There's a lot of low frequencies involved. And of course, our brains work on low frequency, alpha waves, gamma rays, and those frequencies are 10 hertz there. And so these frequencies that they've got, these frame breaks, and there's a lot of low frequency components, and a bit of it you can see there, GSM and DEC phones, 100 hertz. This is all low frequency. So it's not all high frequency. And also on the carrier wave, you actually got the modulations as well. It was interesting too, because a group of 2 researchers in the Netherlands, Hans Giesink and Dirk Meyer, looked at the various low frequency components. And what they found was that these green areas here, some frequencies are not antagonistic towards biology, but other frequencies, the red there, basically not interfere with our biology. So they actually mentioned to the mobile phone companies, look, why don't you change the low frequency frame breaks to be more beneficial to human biology? But the mobile phone companies said, "Look, go away. We don't know. We don't believe this. This is all nonsense." Of course, which I think is very important research, because you could change those frequencies to be more, those low frequency components to be more in harmony with our biology rather than antagonistic. And so, yeah, I thought it was quite interesting. As I said, these simulated, when they do these experiments on the animals and the cells, they use simulated signals because it's convenient. But sometimes they use real mobile phone signals. They put the mobile phone in the cage of the rats, and they switch it on and off and that. So the research can be divided into two areas. That research using real mobile phone signals, and as you can see, the amplitude and the pulsing varies quite dramatically. Or you can use simulated signals. You can use signals that aren't pulsed, or you can put in artificial pulsing into it. And the interesting thing about that is in vivo, the animal studies, you see, and I did this some time ago, I probably should redo it, 120 effect papers and 18 no effect papers. So there you see, with real mobile phone signals, you see a clear difference between the number of effect studies and the number of no effect studies. When you go across to simulated signals, when they're using experiments, simulated signals, the contrast there isn't so great. And again, with cell studies, there's quite a sharp contrast. When you're using real mobile phone signals, you see a lot more effect studies than no effect studies. And similarly, when you go across in vivo with simulated signals, the effect there isn't, it's 50-50. It's not very clear that they're. So real mobile phone signals are quite different to simulated signals because the amplitude and pulsing is quite erratic. I want to talk a little bit about a trigger point. When do you employ the precautionary approach? Okay, you see all these bioeffects and that, but at what point do you actually apply some precaution in your setting the standards? It's two factors: strength of evidence. How strong is the evidence, and the potential costs of doing nothing. Okay, you see all this evidence, but how much is it going to cost long term in terms of treating people with brain cancers and other cancers? A bit like smoking. The strength of evidence was very strong, and it wasn't until it was realised that the cost. Okay, they were getting the tobacco excise. They were getting taxes, getting money from the sale of tobacco, but they suddenly realised in late 1970s, hey, hang on, wait a minute, was all these people with lung cancer, that's actually costing us quite a lot of money. The healthcare system is being stressed by this, so. But let's have a look at how much money are we getting in from taxes, and how much money are we paying out for healthcare. And hang on, we're paying out. These people with lung cancer, they don't die straight away. They linger on for quite a number of years, and we're doing cancer treatment. It's quite a costly exercise, and often the true explanation isn't known for some years later. For example, with asbestos, in 1898, the asbestos miners were getting lung complaints, but it wasn't until 101 years later that we actually did anything. And similarly too with smoking. Sir Richard Dole, 1952, 2000, smoking ban didn't appear till 48 years later. I can remember being on a plane in the 1970s, and you could smoke. You could smoke at the back of the plane. It was okay. And the Dr. John Snow, who was the father of epidemiology back in 1854 and 1833, people were dying, and he didn't know why, but he thought it was the water. It had something to do with the water. So he took the handle off the pump it was in London. He took the handle off the pump, so he stopped people drinking the water out of that well, And suddenly people weren't dying anymore. So he knew the problem was in the water, but he didn't know that what it was until 29 years later, cholera. The current because I want to talk about the regulations and where they're set and why they're set. The regulator is the Australian Communications Media Authority, the ACMA. Now, the ACMA are not a health. They're not a health regulator. They don't pretend to know anything about health. So the ACMA. So what they did, the ACMA has to pick a standard, some standard by which mobile phone companies can work with. So the ACMA adopted the ARPANSA standard. Now that's also the same standard that was set by the International Commission on Non-Ionising Radiation, ICNIRP. You can sort of, they had a standard. But this standard, ICNIRP standard, is based on short-term heating. It doesn't look at all these long-term non-thermal effects. It basically doesn't, it doesn't believe that they have any health implication. Anyway, the ACMA, I wrote to Minister Hunt quite a long time ago now, and I said, look, why don't you include the precautionary principle, in setting up the standard? And his reply was the inclusion of the precautionary principle in the ACMA regulatory instrument would place a regulatory burden on industry, which would require strong justification. The ACMA does not discern that justification. So there's no precautionary principle associated with that. And I'll talk a little bit about why the regulations, why it's important to have the precautionary principle in the regulations. So that was his remark back in 2014. So what we've got now is a situation where the Australian Communications Media Authority actually gets money from selling the spectrum. We all benefit from that. There's a tax, and it's I think it's billions of dollars over 2 or 3 years. It's quite a lot of money, and so they're selecting the standard. They're getting revenue, but they're selecting the standard, and they've selected the ARPANSA standard. So we've now got the situation where the fox is looking after the hen house, which it really shouldn't be like that. The ACMA, they think because they've selected the ARPANSA standard, they put themselves at arm's length. But in fact, the ARPANSA standard is not the standard that it's an occupational standard. It's not really a standard for 24/7 exposure of people. So yeah, so they said the Australian Communication Media Authority is not a provider or regulator of health services, and as such, the ACMA cannot provide advice about potential health impacts of these radio communication devices. That was the CEO back in 2013. The ACMA lacks staff with medical experience and suggests that ARPANSA has a moral responsibility. Problem with that is ARPANSA doesn't have any doctors. It's full of people like me, physicists and epidemiologists. When as I said, in uranium mining, it's very involved in uranium mining and particularly worried about radon gas and the exposure of miners to radon gas, which is present in uranium mines. And we know it causes lung cancer. And in setting those standards, we used to get around a table with doctors. We had different opinions. We had the industry there. We had ourselves, the Australian Radiation Laboratories, which is now ARPANSA, and we had medical people surrounding us. The telcos, Telstra, had a medical doctor some years ago as an occupational health doctor. And he was starting to see a bit of a problem, and he was basically he was told shown the door. So the problem we have is that these standards are basically, current standard is basically not really for population exposure. And I want to talk a little bit about standards and philosophies and radiation protection philosophies. The ICRP is International Commission on Radiation Protection. They're like insurance companies. When they get into that, you've got the high level exposures, but when you get into this low radiation dose, they become like risk managers. Okay, they have principles like as low as reasonably achievable. Can we lower the exposure and still have the same result? How do we manage this low dose area? They become very cautious. Whereas the ICNIRP, ICNIRP and ARPANSA, that standard, they're like judges. They want positive proof. So they're a club of thermal scientists. Heating's the only thing you got to worry about. All this low exposure, it doesn't really come to anything. And interestingly enough, they've got rid of that statement now, but they did have a statement. ICNIRP did have a statement: people being protected. However, not all children and elderly and some of the chronically ill may be affected. And that it's interesting. We pointed this out to ICNIRP. Look, you've got to take into account that populations aren't homogenous. They're not all the same health status. You've got people in the community who've got immune diseases. You can't apply a short-term heating standard to population groups that are being exposed 24/7. You can't do that. It's not. You've got to get into the risk management area. You've got to start risk managing that area. They deleted that sentence about children and elderly, chronically ill. They've taken that out of their new revision, the ICRP 2020. They've taken that statement out there. And I queried them about that, and I said, "Oh, look, why have you taken that statement out of there? It's a valid statement." It's only this was about UV. It's not ultraviolet. Yeah. Anyway, not all countries adopt the ICNIRP standard, the short-term heating standard, what we call the cooking standard. Not all countries adopt that, and you can see there's a range of countries there that have taken a more conservative view. And in particular, Russia has taken a view 100 times lower. They see this as a problem with children. They say, look, you can't expose people 24/7. You've got to really look at a much lower standard. And but there's a lot of pressure on these organisations, radiation protection organisations in these various countries to adopt the ICNIRP approach. In other words, a short-term heating standard. And Salzburg there, they've got the lowest standard, and Austria, but the Austrian government has actually adopted the ICNIRP standard. They say, Salzburg can do whatever they like, but we're nationally we're going to adopt the ICNIRP standard, the short-term heating standard. No, but yeah, so there's a lot of pressure on various governments to toe the line. The evidence of harm and the effects are known for more than 50 years. There's papers back in the 1970s and 80s which said, look, heating isn't the only thing you've got to look at. There are biological effects here. We're seeing them in radar technicians and that. We're seeing these weak fields having a bioeffect. But we've got to take this into account in setting guidelines and standards. So we're currently G and future G. Where are we heading? Well, with this millimetre wave or the higher frequencies, they're attenuated more in air. So it can't go as the actual radiation doesn't, it gets attenuated, it can't go as far. So they're looking at putting probably on every third street pole, there's going to be an antenna. Uh, because it also, it's very directional. You're going to have to beam it to the person with a mobile phone. It's not, it's not being irradiated in all directions. And the higher as we go to millimetre waves, it's going to be more targeted. So as you walk along the street with your mobile phone, the beam on the pole, on the telegraph pole, on the power pole is going to point towards you and direct its beam to you. And they say, oh, at least, this is a good thing. It's actually going to personalise the exposure. If you're, people around you won't get exposed. It's not in all directions. So, yeah, but hang on, scatters off surfaces. Yeah, yeah. So, yeah, it's interesting, isn't it? And we're going to get, rather than being beamed in all directions, it's called what's called massive multiple input, multiple output beam steering technology. This is all going to happen over time. You might not be aware, but there was actually a 5G parliamentary inquiry, Australian parliamentary inquiry into this in September. It went from September 2019 to March 2020. And so they had hearings from different people. 24 witness groups were were in favour of 5G. 6 witness groups weren't. We were one of those. Also was saying, look, we've got to be a bit more cautious about this. And one witness group was sort of a bit uncertain. The interesting thing about that was the 85% of all the submissions were on health. People were concerned about health. And they they said, look, we're going to ignore all those health submissions because health's not on the agenda. We're okay. We've got the ARPANSA standard. There's no health problem here. They didn't want to talk about it. But as I said, 85% of the submissions were on health. And one of the submissions that I thought was really interesting, and you can go to the website, the parliamentary website, and you can download and look at some of the submissions. But I thought this one was very interesting. And he says, Dear Senate Committee, I'll read this out because I think it's very interesting. I'm a senior radiation systems engineer and have worked in the wireless industry for over 30 years, including Motorola for over 14 years. I now work as an engineer manager in support of government radio networks for emergency services. I've had personal experience of high health impacts in our family from low-level wireless radiation. I feel I must strongly advise against the intended 5G rollout due to health impacts experienced to our family. I used to believe that non-ionising radiation was safe at low levels. I studied the ARPANSA standard for non-ionising radiation and took safety courses as part of my employment to understand what the safe limits were. In 2014, we moved into a new house in southwest Sydney. We found the internet was not available from either ADSL or NBN. So I happily welcomed the local wireless internet provider to install a 2.4 gigahertz and 5.8 gigahertz by 3 section on the base station on my roof. And you can see it there, it's got on his roof. This provided internet for us and 42 other homes in the local area by the time we asked for it to be removed. After becoming aware of the potential impacts to our daughter's health with severe autistic-like symptoms, we demanded the removal. It took 8 months of demanding its removal in December 2018. After the removal, many of the daughter's autistic symptoms improved dramatically. I think that's very interesting because here is somebody in the industry putting up a bit of a flag saying, hey, I think there's a problem here. So with ionising radiation, we have principles of optimisation and justification. we have that approach. But now we've gone to this wireless technology, and we've got a problem because we've got wireless technology, the therapy, and like for example, cochlear implants, which have a real medical, there's a real medical application and brings hearing to people who are deaf. And so we have the medical application of this radiation, but we also now have the use of this radiation for, say, wireless in nappies, sensing the child has actually urinated, produced a Wheaties nappy. I mean, that to me is really, if you were in the ionising radiation sphere, that would be a no-no. You wouldn't be allowed to do that. It's an application which is not really required. And there was a tattooist on the news some months ago, talking about having microchip implants in their hand to open the car door. So he waves his hand with the car door, and the car door opens. He's got this chip in his hand. Hang on, maybe that will cause a problem with your cells. Maybe that might be a cancerous. It might produce cancer in your hand. It doesn't sound like a good idea. So the actual difference, the medical application and the consumer application have now got blurred, and I noticed they've got sunglasses now that have cameras on them. I think there's a problem here. There's no control. It's sort of out of control. There's no principles of optimization and justification. And those principles we have in ionising radiation, like as low as reasonably achievable, does it have to work at full power? Can it work at a much lower level? Those principles are basically not talked about. And, Julie mentioned about bees, and these millimetre waves, as the wave now becomes the size of the object, you get transfer of energy much more efficiently into the object. And of course, millimetre waves, what bees are the size of millimetres. So these millimetre waves are going to impact bees. But don't worry, Monsanto's got a solution. Once all the bees are gone, we can have genetically modified ants that can go around and pollinate. It sounds like a really good idea, doesn't it? I don't think so. So what are ARPANSA's conclusions? Converging evidence of health effects, non-thermal bioeffects, they're real bioeffects. We see them in the animal studies. Why is there 5G biology? Why is there no 5G bioeffects research? We're releasing this technology and there's no research. The research can't keep up with the way this technology is being used. The problem we have is that university research is now supply and demand driven. If nobody stumps up the money to do the research, then the research doesn't get done. It's market driven. Devices need to have a higher safety design standard. I was just made aware of motorbike helmets. So they put a transmitter on the side of the motorbike helmet. It's a 100 milliwatt transmitter. Hang on, I went looking to see whether there'd been any actual testing to see what the exposure was inside the helmet to the person wearing this transmitter. It can talk to other motorbikes, it can talk to mobile phones. And the answer is, I found one paper, and it was measuring the power density or the exposure of a pillion rider to the bike rider, the two helmets were a short distance away from one another. And so that was the only paper I could find. There's been no testing. Oh, it's a good idea. Oh, it shouldn't be a problem. Yeah, stick it on the side of the helmet. Uh, as I said, the research isn't being done. The stronger consumer advice on safe use, better than if we are concerned. Yeah, well, no, you need to give consumer advice, especially for children, on the safe use of these devices. Um, uh, yeah, there is a safety uh, in your mobile phone. You'll find there's a paragraph in the regulatory area about the safe use of mobile phones, and you're supposed to use them with an air gap. But the reality is that's not the way people use it. They jam it up against their head. And once they do that, the standard, even their own cooking standard, even their own eating standards are exceeded. Advice needs to be very, very obvious. You need to have upfront. And finally, I think a trigger point has been reached for adopting a more precautionary approach to this new RF EMR wireless technology. I think we've got enough information now to realise that the standard is set far too high, and that if you change the limit, you change behaviour. You know, you can see that on the roads. I mean, you change the speed limit, you change the behaviour. People don't go as fast. And that's if you bring down the limit and say, look, industry, you can't work at this limit. You've got to go at a much lower limit. They'll innovate. They'll meet that requirement. But at the moment, there's no need to innovate because the standard is set on the basis of short-term heating. There's no risk management precautionary approach to this technology. So, as I said, the guidelines are set on the basis of short-term heating, and that's the wrong standard for 24 exposure of populations. Completely the wrong standard. Yeah, how can you reduce your exposure? Well, for example, don't sleep with a mobile phone next to you in bed. I mean, it's not a good idea. You can switch it off. You don't need to have the phone on. Use a corded solution. I've got a corded phone here. I use a corded phone all the time. Use wired solutions where possible. Turn off when not in use. You don't need the wireless on at night when you're asleep. It's not necessary. Yeah, use airplane mode. Talk speaker free, hands free. Talk hands free. Don't jam the phone up to your head. Not a good idea. Distance is with radiation. All radiation, distance is your friend. Don't have it on your body. Don't put it in your pocket and irradiate your boys. It's not a good idea. But where's the consumer advice on the safe use of these devices? There is none. Thank you.